Hi, everybody. Good morning. All right, I guess there's a lot of you here, so you didn't party too hard last night, or you're like me and you just come anyway. So I'm Chris, I'm from Microsoft, and I'm going to be talking a little bit about reactive development on mobile with Realm database. Now, before I get started, this is a native mobile talk, but this isn't really a native mobile talk. This is a talk about design, and this is a talk about patterns. So just spoiler alert, you're going to see some Swift code. Try not to panic. The concepts that you see are broadly applicable to a lot of technologies, and Realm database that I'm going to be talking about a little bit does have a React Native library, so you can use it with React Native. I personally haven't, so if you have some experiences with it, let me know. Without further ado, do you need a local database in your mobile application? I would argue yes. Yes, you do. There are a ton of options out there nowadays. It's not like the old days. Then the traditional solutions to storing data locally on your mobile device are really insufficient. If you're, so talking from an iOS perspective, if you're using user defaults, you're doing it wrong. And if you're like storing it in a local JSON file or something like that, you're doing it wrong. These are not performant. And moreover, there's no reason not to use a local database nowadays because there are so many options out there and they're all great. By this point, I'd even say they're pretty battle tested. But I'd say it's not enough to use a local database. No. I would say you want a reactive one. And what does this mean? This means this is a type of database that allows you to actually observe changes to the data in your database. And there's a few of these options out there nowadays. I'm going to be talking about Realm, but there are other options out there, and I like Realm personally, but I think any of them will work. So the basic concepts are, in order to transform a traditionally imperative mobile application into a reactive one, you need to just follow these two pretty simple principles. One is that the local database is the source of truth. And we'll see an example of this in a minute. The other is that what follows naturally is that the UI is reacting to changes in the database. As I mentioned, the database is reactive. So when the data is changing, your mobile app can react to those. So what's the architecture? Well, if you come from a mobile background or if you've hung out with mobile developers wherever they are, you've probably heard about them talking MVC, the model view controller. But nowadays, that's not really enough. We also need this data sync layer at the bottom, what I call it, which is on the top is a database, and this connects to your API. Or it could be push notifications or some workers, whatever it may be. In reactive programming, it's often said that everything is a stream. And if you're a mobile developer, this isn't a natural concept. And so I would just challenge that for a moment and say maybe you can think of everything as an event. With mobile, that's a little bit more intuitive. And how does that work? Well, you have a user somewhere interacting with your app, hopefully. And this event comes down into the user interface. That's your view. And from there, you're receiving the event in your view controller. From there, it goes into your models or your managers, which are maybe singleton instances, similar to stores. And then from there, what you're going to do is write to your database, maybe. From there, events propagate back up. If you're using a reactive database, then you've got changes occurring in the database. Your models are reacting to those changes, and your view controllers are reacting to those changes, and your views are then updating. But there's also events occurring in your data sync layer. So your API, you could have a worker that's completely asynchronous, that's just pulling data from your API, or maybe you're receiving push notifications, something like that. The point is, your app is completely agnostic to what the source of your data is. Your app doesn't care. Your app only cares about the local database. That's your source of truth. So there are events occurring between, say, your server or some long-running process calculation in the background. In your database is in real time being notified of these changes, and your application in turn updates. So, yep, user app, and the internet is down there. Again, this is the part that I really want you to focus on, because this is not the traditional model that's talked about in mobile. So as I mentioned, I like Realm, but there are several alternatives out there. I'm not an evangelist for Realm. I'm not involved with the company in any way. But for me, as somebody that's coming from a Rails and a SQL backend, I kind of like how it's working, and I will show you an example of it. But again, the key, it doesn't matter what your database is, and there's actually a lot more options out there for Android, so if you're on that side, then you're a lot better off. But the key is that you want a database that supports query observation, and again, that is what makes it reactive. All right, so now I'm going to tempt the demo gods and show you a real live example of this all running. And this is very real. It's a sample app that I wrote fairly quickly, but I did incorporate all the layers that you would normally use in an application. So let's see, script. I'm just going to start up my server here because I have a real server running in the. Oh, I need sudo because I'm the man. There we go. So I have a Rails backend running here, and let me get the logs out. Let's see, Docker logs. Probably this one. Goodbye. Okay. Let's see if that's live demos. Script run, and let's see what's going on in the foreground. Oh, I think I've already got an instance running, so let me just turn my backend off, and then I will get it going. Sudo docker compose down. Okay, and let's try that again. There we go. Okay, that's looking better. Anyway, here's my app. Here's my dog. And so the application, I actually wrote in a couple days. I was using Apple's AR kit. And again, this is a reason why you might want to be doing something native as opposed to, say, with React Native. All right, so this is a pretty simple application. What I have here is what you're seeing is a leaderboard, a scoreboard. I'm going to enter a name. I'm going to create a new user, and then we're going to show you a little AR game that's we'll see in real time is going to be sending out the user's score. So what's a good name? Let's say Boris. Boris sounds like a good name. All right. Now notice my UI has updated. I'll come back to that in a minute, but just take note that the text box is no longer there and we have a label. So here we are, and here you guys are, and there's some bugs. Now I want you to pay attention on the top left. You'll notice that as I'm tapping these bugs, the score is increasing. And then as the bugs come too close, the health is decreasing. And eventually we get game over. So, and just to show you that this is in fact connecting to the backend, if I go all the way back up here, I think we will find that there is somewhere an entry for creating a user session with a Boris. So here's my server. So this, it's a simple application, but these are very real components, and I'm using Realm, and I'm using an actual API and an actual backend. So this isn't like a really toy example. So first point that I want to make is here, and again, it's Swift code. I'm sorry, but it probably looks like something you've read. So what happens when I created that user? So I entered a name, right? Entered a name in my text field, and then what happens, I hit enter, and then I'm taking that text, and I'm sending it over to this manager instance that I have, and this is making an API call to sync the user session. That's it. It's totally fire and forget. What happens, this is my API layer. Remember in the model that I showed you have the status sync layer. So the user, when we get a successful response, we're saving the user locally. There's no big callback chain. There's nobody is like just sitting around and waiting for this. There's no messy stack to worry about. It's a completely fire and forget model, very simple, very clean. So then what happens when the user is created? Well, I have a listener here, and this is more or less what a change listener would look like, and the interface will be the same in other languages. But what I'm waiting for is if there is any change to the local state of users in the database. In the case of an update, I check that there is one user. And if there is, then I create that text field, the button that you saw before that said, hello, Boris, let's get started. So that's an example of updating the UI based on, and I hope you noticed that was quite fast, even though I'm making an API call and it's going out to some Azure cloud somewhere, which is not the fastest one because I'm cheap. And it's quite reactive. So the second thing that I want to point out is that during the actual gameplay, and I'm going to look here in the scenes, in the game scene. And I apologize again. This is some AR Swift code, so probably it's not super familiar, but you can kind of understand what's going on here. When I was touching the screen to squash those bugs, I get touches began events, this is just a touch handler. And then I check to see if I've hit anything, and if I do, then I call increase score. Now you remember on the top left of the screen, we had the score increasing as I'm squashing those bugs. What does increase score do? It finds the current user, which is, again, this is set by a listener, but I'll wave my hand at that for now. So we find the current user, and then we're making just a simple database call to increase the user's score. Then somewhere else, I have a listener that is actually sending these updates over to the server. So you'll notice that I have these calls with score here being updated. Now, the reason why I want to point this out is because this is all running on the main thread, which is a horrible idea, but it is all running on the main thread in an AR game. Just let that sink in for a moment. You're not seeing, we're writing to the database, we're reading from the database, and we're making API calls. And so the API calls are happening in the background, but we're triggering those API calls all on the main thread synchronously while we're running an AR game. So it is quite performant, and I have done a bit of load testing with it, and I was pretty impressed by what it could handle. The last thing that I want to show, and this is really the big aha moment for me, what really makes this whole thing worth it. So here's my server, and as happens with servers, as you just saw a few minutes ago, things go wrong, so let's kill it. Let's kill the server. There was an outage. Oops, don't know what happened. So here I am. I'm going to sign in as Boris again, and I don't know, what would you expect to happen? Well, as a user, you don't really want to stop playing your game, right? I mean, you don't care if somebody's server went out, if someone forgot to pay their bill or whatever. You just want to keep playing. And you'll notice, obviously, I'm not getting any more logs here because my server is dead, but the game is working just perfectly. Why is that? It's because it's designed that way. It's designed to work seamlessly offline by virtue of the fact that the local database is the source of truth. And when you do that, it transforms your application amazingly. You don't need to worry about outages or if your notifications aren't coming in or whatever. You have the updated state that you need in your local database, and you're just working off of that. And so the online-offline thing that's going to happen inevitably to somebody, that's already handled by virtue of the design. So I think this is a really powerful way to get what would normally take a lot of explicit forethought. It's sort of you get it for free, which as a mobile developer, oftentimes you're working on a limited resource, limited time budget. That's something that you really want. By the way, all this code that you saw, if you really want to learn more about Swift and the very odd example of ARKit in iOS, it is on GitHub, so you can feel free to clone that and leave nasty comments or whatever. So benefits, as I've just shown you, it's pretty easy to support the online-offline experience seamlessly because your application logic, your business logic doesn't care. Your source of truth is here. It doesn't matter how it got there. It doesn't matter how it's changing. It's right there. The business logic, as I've shown you, the business logic concerns are cleanly separated. So, when you start writing a mobile application, everybody says, oh yes, model, view, controller, and then suddenly you're doing API calls from your view, and suddenly you're writing to the database from wherever, and this interrupt, this dirty bleed over of the design, yeah, that might work for you if you're one guy sitting in a garage, but talking from somebody who works on some pretty large applications in my day job, you really want a clean design, as that's what provides scalability from a team perspective, from a project perspective, scalability, a project that's going to live a long time, and you're going to be able to reuse that code, and new engineers are going to come in and not go like, whoa, what is happening, because this design doesn't make any sense. It's clean. Another really cool part, I think, for me, is that the mobile architecture now kind of resembles your hosted web architecture. So the same way that in your web application, you have a database somewhere, you have maybe some workers somewhere, and then you have your front end somewhere, and you can think of these as completely separate components. And in fact, many times these are like completely separate, repos or Docker containers, etc. And so now you can really mirror that in your mobile application, which I think is a powerful way to think about that. But I like to be honest, so there's Realm in particular has some disadvantages. if you have an application, like let's say, I don't know, you've got 30,000 lines of code and you say, hey, Realm, that looks great, let's try it out. Well, you're not really going to like try it out. You're going to spend about a week kind of refactoring your models and moving things around. It's not really super easy. It's not something you just like, npm install or pod update in the case of iOS, but onboarding will take some time. It will take, the learning curve is not super high, especially if you've worked with something like Sequelize or Active Record with Rails, but actually incorporating this into your application and making sure that all your models are compliant with the Realm schema is not like, it's not one of those. So. You have to be careful with object nesting. So we saw an example of like, if the user gets updated, then I want a callback. Well, so here's an example. Let's say you are listening for changes on, I don't know, let's say you've got a house model, and you're listening for changes on a particular house model. Well, and you're updating, re-rendering some part of your UI when that house model changes. Well, that house contains some rooms, and those rooms contain some people, et cetera, and these are all modeled in the database. What's actually going to happen is if somebody's shoe color changes, that is a change on the person, that is a change on the room, and that is a change on the house. And so you might actually end up getting a ton of callbacks when you don't really want them. So you have to be careful with object nesting. And the reason why I bring that up is because your API may be designed, your data model on your backend may be designed in such a way that the objects are supposed to be nested in a certain way, but you don't necessarily want to do that on mobile. And then the third one is, maybe this is French to you guys, but NS dictionary, and there's a lot of native, like if you're used to the native object types, they're not all perfectly supported. There are some and NS dictionary is an example, which is basically if you have a property of a model that's a dictionary that doesn't fly in Realm, you can't actually store that to the database. And that's all she wrote. Yeah, so I'm Chris. I'm a software engineer at Microsoft. I don't actually work on mobile during my working hours, but I used to, so. Yeah, and feel free to reach out to me on GitHub, or you can, God forbid, check out the product that we're working on, which is called App Center. But I'm not going to do a plug, sorry. So that's it.
Sorry.
My man.
We'll pick one of the questions if you don't mind.
Yeah.
And here we can read this question from Alexander. What if you get conflicts when you get back online in that scenario?
Yeah, I mean, you probably will, right? So again, I want to keep this as general as possible, but you need to have a model of how you're going to handle conflicts kind of from the start, and that's often going to depend very much on just the specifics of your application or whatever. I mean, there's some things that like, if your user's authentication information has changed on the back end, obviously you want that to persist, but if somebody has made some less system important change to some local model, you'll probably want that to persist. Ultimately you'll need to implement some sort of conflict handling. I'm sorry I don't have a more elegant answer, but I mean, if you want the simple way, is you just, last in wins and see if that works. But yeah, it does require a bit of forethought and design there.
Cool. If you have any more questions or you want to get more details about Chris' talk, you can reach him after this talk. So thanks a lot again. Cheers.